Hello, hello. Am I live? So, hello everyone. Hello, and a very good evening to all of you. I'm sure all of you are really excited to know the answers and actually discuss how was the level of paper. I hope your paper went really well. So, I'll just wait for a minute. I think I'm not live. I'll just check once. Hello, hello. Am I live? So, I think I'm not live. Let's check once. Hello, hello. Yeah, so I am live. So I am really hoping that your paper went really well. And honestly, I agree that physics paper was slightly on a tougher side, but not exactly tough. It would be really great if you can just drop in your like how your paper went. If you can just drop in your messages in the chat section. I just want to know from you people first before beginning the discussion that how did your paper go and what do you feel like the paper was really hard, very tough, moderate, or it was on a easy side, it was just similar to the pyqs, or like how do you people feel the exam was, right? And then we will begin with discussing the answers. So what I'll do, I'll discuss each and every question one by one. Along with the answer, I will discuss the solution as well. Like if a question is pretty straightforward, then we'll just discuss the answer. If it's just a formula based question. So if anyone can just share their experience or how do you feel the paper was. Okay, so first of all, like before starting the discussion, I personally feel that the exam, especially like I'll be talking about the physics section particularly. So I personally feel that the paper was not as easy as it was on 3rd May, but it was not too difficult as well, right? Like according to me, like out of 45 questions, I feel 10 questions were pretty straightforward. 10 questions I would classify them as easy questions. Then around 12 to 15 questions, I would say they were pretty difficult, right? Difficult as in, like there was, I think, no question that was out of syllabus or something like which you haven't studied at all, or it was a really difficult thing. Nothing of that sort. At least I didn't observe any such question. But I do feel that there were certain questions, around 12 to 15 questions, wherein you were supposed to apply two or three concepts from two or three different chapters, right? So I believe that those 12 to 15 questions, because those were difficult, and then like maximum number of questions, I think like around 20-22 questions, they were moderate. So personally, I feel that the paper was on a from moderate to hard difficulty level. But I feel like this time they have again taken the standard of the paper back to the time when AIMS exam was conducted separately and NEET UG was conducted separately. So like they have taken that level back to that time, right? So now this year, this time the paper was not really easy. The questions, all the questions were not formula based. So without wasting any time, let's start with our paper discussion. Okay, so we'll just start discussing with the very first question. I hope my screen is visible. So we'll just start with our very first question. So over here, your first question says that an ideal gas is made of polyatomic molecules. Polyatomic molecules are given, and you are told that each of the molecules has three translational. The number of degrees of freedom are actually given, like the number modes are given. So three translational, three rotational, and then f number of vibrational modes. F number of vibrational modes are given. You are also given that if the ratio of heat capacities, that means they are saying Cp by Cv, the value of ratio of heat capacity Cp by Cv is given as 8 by 7, and you are asked to calculate the value of this F. So we already know that the ratio of heat capacity Cp by Cv, this is actually equal to degrees of, I'll just use some other symbol other than F, otherwise you people might get confused. So this formula is D plus 2 by D, where D, like I am using D for representing degrees of freedom, right? So over here, if I want to calculate the degree of freedom of this ideal gas, then this degree of freedom will be 3 plus 3 plus, so now F should be multiplied by 2. Why am I multiplying it with 2? You people must know that in case of vibrational mode, so each mode of vibration contributes 2 degrees of freedom. One was for kinetic and one was for potential, right? So each of these contribute 2 degrees of freedom. So we multiply F by 2. Now total degrees of freedom becomes 6 plus 2F. And if we first solve this equation, this becomes 8D is equal to, sorry, not 8D, it becomes, this is equal to 8 by 7. So this becomes 7D plus 7 2s are 14 is equal to 8D. So D comes out to be 14. Degrees of freedom comes out to be 14. Then degrees of freedom should be equal to 6 plus 2F. You equate this with 14. So you get 14 minus 6, 8. 8 divided by 2, 4. So the value of F should be 4. So the answer of the first question should be option number 4, and the answer is also 4. Now moving forward to the second question. So second question, you can just mark this question. So there is a small discrepancy within this question. I'll just discuss that. The question says that one main scale division of a vernier caliper is equal to 1 mm. That means 1 MSD is equal to 1 mm. And then you are given that the number of divisions on the vernier scale is 10. The value of n is 10. So both these things are given so that you can calculate the least count. So we already know we can calculate the least count by main scale value of one main scale division divided by n. So least count will come out to be 0.01 centimeter. And then you are given that when both the jaws touch each other, the vernier scale shifts to left of 0. Left of 0 of the main scale in such a way that fourth vernier scale division coincides with division of main scale. Now the problem with this question is that over here, because they are saying left of 0, this means it has this vernier calipers has a negative 0 error. It has a negative 0 error. Because it has a negative 0 error, so how do we actually calculate the negative 0 error? I'll just calculate it over here. So negative 0 error, the formula for calculating it is minus least count multiplied by n minus VSR. That means the number of vernier scale division coinciding with the main scale is VSR. N is the total number of divisions, LC is the least count. So this comes out to be minus 10, minus 0. Minus 0.01 multiplied by total number of divisions 10, and then because they are saying left of 0 and fourth vernier scale division coincides, so when you calculate, you will take this as 6. Now negative 0 error will come out to be 0.06, and when you calculate the reading using this value 0.06 centimeter, you are asked to calculate the actual length. The measured length is 1 centimeter. You are asked to calculate the actual length. Now actual length will become 1 minus 0.06. Actual answer should come out to be 1.06 centimeter. But you will observe that there is no such option in this question. In fact, the answer is given according to your like the positive 0 error thing, right? So if in case you took this instead of this 6, if you take this took this for 4, then you must have gotten this 1.04 centimeter. But actually I think like this will be a bonus question because there is no such correct answer in this question. Moving forward to the third question. So in the third question, you are given 3 identical PN junction diodes D1, D2 and D3 are connected across a battery as shown in the figure. You are given the width of the depletion region of D1, D2 and D3 are W1, W2 and W3. We need to choose the correct option for the width of depletion region. Width of this is W1, width of this is W2, width of this is W3. Now you need to observe one thing very carefully. So like at the first glance, I also got confused. If you will see for the second diode, this second diode is actually unbiased. It is neither reverse biased, neither forward biased. Why? Because this wire is broken from here, right? So you just needed to look at this carefully. So you can see this first diode, that is a D1. D1 is actually forward biased. D3 is actually reversed bias, and D2 is in fact unbiased. We know the maximum depletion, the maximum width of depletion region comes in your reverse bias. So W3 should be maximum. W3 should be maximum, and minimum depletion width comes in your forward bias. So W1 should be minimum, and because W2 is unbiased, like second diode is unbiased, so the width of that unbiased diode should be somewhere in between forward biasing and reverse biasing diodes, right? So this should be the order: W3 greater than W2, greater than W1. That is option number 2 should be your answer, right? So this was our third question. Moving forward to the fourth question. So fourth question actually says us that consider a spring mass simple harmonic oscillator in one dimension. The mass of the particle is mkg, mass is given m, spring constant is given k. At a given instant, the extension of the spring is x meter. Extension is given n x, speed of the particle is given v. On the xv plane, if the graph of v as a function of x is a circle, we are actually given that this graph is a circle, right? Then we need to find out the correct option. So we know that the formula for calculating the velocity is omega under root a square minus x square. If we simplify this, we get v square is equal to w, we get v square is equal to omega a square minus omega square a square minus omega square x square. And if you simply divide a square omega square on both the sides, divide it by both the sides, so you will get the equation as v square by a omega whole square plus x square by a square is equal to 1. So this is a equation of a circle. Why did we deduce it like this? Because we are already given that x graph between x and v plane is a circle. So this is a circle. In this case, if we see a omega should be equal to a, that means the value of omega should be equal to 1. If omega is 1, we know the relation between k and m. K is in fact equal to m omega square, right? Omega is 1, so k is equal to m. That means answer should be option number 1 in this question. Okay, now moving forward to our next question. Moving forward to question number 5. Now question number 5 says that an electromagnetic wave traveling in a lossless dielectric medium having a dielectric constant is given epsilon r 9. Electric field is given E naught sine kz minus 2 pi 10 raised to the power 6t. So this becomes your omega. E naught is the amplitude. Now you have to read the question very, very, very carefully. Carefully as in you are asked the incorrect choice. By mistake, what we do in a hurry is we just tend to take the correct answer. So I hope you have not committed this mistake. You were asked to find out the incorrect choice. So in this question, if you just use the option, all the options, you will see that in option number 1, we will first check option number 1. We are given the wavelength of the electromagnetic wave inside the medium is 300 meter. You are given the wavelength. If you calculate v using this wavelength, this 300 meter, you can calculate the velocity. Velocity will be omega by k. So this becomes 2 pi into 10 raised to the power 6 divided by 2 pi divided by 300. So this 2 pi gets cancelled with 2 pi. Speed comes as 3 into 10 raised to the power 8. But actually the wave is traveling in a lossless dielectric medium. 3 into 10 to the power 8 should have come if the wave was traveling in air or vacuum, right? It is actually traveling in a medium, so speed would have been somewhat less. But here, using this 300 meter wavelength, we are getting 3 into 10 to the power 8. That means this is the incorrect option. Now, we can also check the second option. Second option, if we check, the magnetic field is given by relation B naught into B naught divided by nu sine kz minus 2 pi. So basically, we can see that this wave is in the direction of minus z, right? If we see, we already know that E cap, basically electric field cross product with magnetic field, E cross B should be equal to the velocity, the direction of velocity. If we say our electric field Ex we are given, that means this is in I cap. We already know that the velocity is in fact in, if we take velocities in k cap, then this should be in the j cap direction, right? And E naught by B naught is actually equal to V. So B naught should be equal to E naught by V, right? So we can see that you are given V is the speed of the magnetic, V is the speed of your electromagnetic wave inside the medium, right? But in the option over here, it is given B naught by V. In fact, E naught by V should have been B naught. So this option is also incorrect. So this question actually had two answers. Again, a discrepancy sort of a question. Let's see what decision does NTA gives when they release the answer key. Right now, moving forward to our next question. I'll just remove this once. Moving forward to our sixth question. Sixth question says a frictionless circular wire of unit radius is fixed on the horizontal plane. You are given a wire moving on a horizontal plane. So this was a pretty much easy question. Actually, the language of this question was made hard. Like the question was look to like it was made to look hard using the language and the length of the question. But if you read the question, they are saying that 2 point particles of unit mass start moving simultaneously. They move from point A, theta is pi by 2 with identical uniform angular speeds in opposite direction. Identical means one particle is coming from like you can also see the arrows. One particle is coming from going this side, one is going this side. Identical, they are saying identical uniform angular speeds. This means this both these speeds are equal. And then they meet again at point B. B is the just the diametrically opposite end. You are asked to find out during this time which of the following figures schematically represent the magnitude of. So you need to find out the total linear momentum of the system. You just need to see that they are starting from rest from this point. That means the total initial momentum. That means the graph should start from 0 because they are starting from rest. And then again they are meeting over here at this point. So at when they are crossing each other, that means when they are crossing each other in a opposite direction, that means the final momentum should also be 0. In fact, you didn't have to calculate the complete answer. You can just check the options. In first option, we see the initial and final value is non-zero. That means this is not the correct answer. Then in option 2, we see the initial momentum and the final momentum both are 0. And then there is some change. If you see there was no other option which had this thing. So over here initial momentum is non-zero. This shows momentum is constant. So option 2 was the answer in this case. Moving forward to question number 7. Question number 7 was actually based on Rutherford's experiment, alpha scattering experiment. For alpha scattering experiment, we know the value of n is inversely proportional to sine 4 raised to the power 4 theta by 2. That means it was inversely proportional to the sine wave. So your graph should look somewhat like option number 2. Graph should have looked somewhat like option number 2. Moving forward to question number 8. Now, question number 8 actually tells you, I'll just move out of the screen for some time. Question number 8 actually says that consider three media PQR with refractive index. You are given the refractive index 1, 1.25 and 1.5. You need to find out, you are given the whole thing, the thickness of medium Q 5 centimeter, and then we are basically asked to calculate the difference between H1 and H2, the magnitude of H1 minus H2. If we see, we need to calculate, we need to calculate H1 and H2. You can say the apparent depth will become the actual depth divided by your refractive index. So actual depth is 5 by 2 in first case and the refractive index is 5 by 4. So this, using this we get value 2, the value of that is, if you see the value of this, where we have medium Q. Medium Q, we have thickness 5 centimeter. That's why, right? So we get this as 2, and then if we calculate the second apparent depth, that is the value of H2. This comes out to be actual depth divided by refractive index. Now in this case, this is 5 by 2 divided by 5 by 4 divided by 3 by 2. If you calculate this and simplify this, this will come out to be 5 by 6. Sorry, not this will come out to be 5 by 6. This 2 gets cancelled with 2. This will be 5 by 6, 5 by 2. If you simplify this height you will get as 3. So you need to calculate the difference. Difference is 3 minus 2, 1. Option number 1 would be your correct answer in this case, right? Moving forward to question number 9. Question number 9 was a straightforward question based on your dimensional analysis part. So question number 9, right? Question number 9, it was a simple dimensional analysis question. In dimensional analysis question, if you see, you just needed to put the the dimensions. So you are given sigma s is the Stephen Boltzmann constant. We already know the dimension of Stephen Boltzmann constant. So Stephen Boltzmann constant has dimension m t minus 3 k minus 4. Then kb was your Boltzmann constant. Boltzmann constant, you can calculate the dimension. Energy is equal to 3 by 2 kbt. The dimension of kb was actually ml square t minus 2 k minus 1, ml square t minus 2 k minus 1. And b is your Wien's displacement. Wien's displacement, it is just a displacement. Displacement is Wien's displacement, we have L into k. You were supposed to find out the dimensional formula for that dimension of sigma k inverse b. Sigma k inverse b. So when you solve this, you just need to put these three dimensions over here. Just make sure this is -1. You need to take the inverse. So when you put all these values, you will get the answer to be option number 4. That is L -1, T -1, K -2. Okay. Moving forward to question number 10. Question number 10 says, for sound waves, is the number of notes for fifth harmonic of an open-ended pipe, and that for the is n, and that for the ninth harmonic of the same pipe with one of its end closed is m. That means for open pipe, for open ended pipe it is n. The for closed ended pipe it is m. We need to find out the ratio of n by m. So we already know that the fifth harmonic for open ended, like the fifth harmonic for open ended open organ pipe, the fifth harmonic was equal to actually 5. And then you are asked to find and that for ninth harmonic of the same pipe with one of its ends closed. When the pipe is closed, then ninth harmonic in a closed pipe basically we need. So ninth harmonic in a closed pipe will also have 5 notes, right? Ninth harmonic of closed-ended pipe has 5 nodes, and fifth harmonic of open-ended pipe has 5 nodes. That means this ratio is going to be come out to be 5 by 5, that is 1. So answer is option number 2, that is 1. This was a simple, like this was, I would say this was a very easy question. If you know the concept, you would have not spent much time on this question. Moving forward to question number 11. So question number 11 says, two infinitely long parallel conducting wires A and B carry current I and 2I respectively in the same direction. A has uniform mass per unit length. So basically, this is your first wire, this is your second wire, and you have some distance between both these wires. This carries 2I current, this carries I current. And then you need to find out, you are given that the wire B is kept fixed at a height h above the floor. This is your wire B, this is your wire A. Minimum magnitude of h so that wire A does not rise from the floor. Wire A does not rise from the floor you are given. So basically your total energy should be fixed, right? So on first on the LHS you can say that length is L, length of the wire is L rho lambda into G should be equal to electric field, magnetic field will come out to be mu naught 2 I by 4 pi h, 2 pi h, sorry, mu naught upon 2 pi, 2 I by h into I into L. L gets cancelled out with L, 2 gets cancelled out with 2. Then you were supposed to find out h. H comes out to be mu naught I square divided by pi lambda G. Mu naught I square pi lambda G. So over here, if you see, this should be option number 1, because in this question, this option I can see 2, over here also 2, and this 4. So option number 1 according to this paper. Question number 12. This was again a very simple and a easy question. Only difficulty was like you would have spent some amount of time in calculating the XC and XR. You are given a LCR circuit. You are given the value of LC and R. You are given omega. This is omega 2 into 10 raised to the power 3. You were asked to calculate the current. In this question, you were supposed to calculate XC and XL, and you will notice that the value of XC will come equal to XL. That means your circuit will behave as a purely resistive circuit. That means your impedance will actually be equal to R. and your current will come out to be V naught upon R. So V naught is 220 and your resistance is 100. So your current will actually come out to be 2.2 ampere. But like this question must have, tricked you somewhere if you made some or the other calculation mistake while arriving at this conclusion that Xc is equal to XL. Next, question number 13. You were given a uniformly charged insulating sphere with radius r, total charge capital Q. A point charge small q with a mass m is released from rest at a distance of 3r from the center. You were asked to find out the value for your speed, right? So you are given this is your charged sphere. There was a particle, a small charge minus q kept over here having mass 3 small m. Distance is 3r from the center. It's given over here. And you were asked to calculate the velocity, right? So you can just use make use of the conservation of energy. That means your initial kinetic energy plus initial potential energy should be equal to finite kinetic energy plus final potential energy, UF, right? I'll just change the color and thickness somewhat. So initial kinetic energy is 0, particle starts from rest. Initial potential energy minus q, k q by 3r. Final kinetic energy half mv square, and final potential energy is minus q, k q by r. You just need to simplify this equation and calculate V. So when you simplify this, your half mv square will come equal to 2 by 3 k capital Q small q by r. And when you simplify, your V velocity will come out to be capital Q small q divided by 3 pi epsilon naught m r. You just need to substitute this k by 1 upon 4 by epsilon naught. So over here, your answer will come out to be option number 2 according to this question paper. Moving forward to question number 14. Now question number 14 says a beam of light falls on a metal surface, photoelectrons. This was a question from dual nature. You were supposed to find out the represent the graph. So first graph is for current and the other graph is for stopping potential, right? You just need to make sure that for in case of current, if I talk about, you were given that your power of light source starts to decrease linearly with time. That means if this is power is energy upon time. Energy is basically n, that is number of photoelectrons divided by into multiplied by energy of one electron h nu divided by time. So if your power is decreasing, that means your n is decreasing. If your n is decreasing, that means your current should be decreasing with time. But if we talk about stopping potential, then stopping potential, your formula for stopping potential was EV is equal to EV naught is equal to H nu minus H nu naught. That means like this was the work function. Your power is decreasing, right? Power of the light source is decreasing. Frequency is actually not decreasing. So your stopping potential only depends on the frequency, incident radiation frequency and work function. None of these two things are changing. That means stopping potential should remain constant. That means we need to look for some graph where current is decreasing with respect to time linearly and stopping potential remains same. So first option is incorrect, second is incorrect. Yeah, so we see option number 4 will be our correct answer in this case, right? Now moving forward to our next question number 15. Question number 15, you are asked to calculate your say given two planets equal mass, radii r1 r2, r2 is equal to r1 by r2, escape velocity. You need to find out the ratio of escape velocity. Escape velocity formula is root g m by r. So that means escape velocity is inversely proportional to root r under root r. You need to calculate the ratio v2 by v1. v2 by v1 will come out to be root r1 by r2. R2 is R1 by 2. So this will come out to be root 2. And yeah, this will come out to be root 2. So your answer will be option number 2, root 2. Moving forward to next question. Question number 16. This was actually a interesting and a good question. Somewhat difficult question, I would say. You were asked to calculate the magnitude of total work done, right? Total work done you were asked to calculate. Like this was given. So you need to calculate the total work done and equate it with this, and then you will be able to calculate the value of n. So in fact, for calculating the work done is basically equal to change in energy, delta U. So what we can do, we can, for calculating the energy, we can calculate the change in potential. That means VA minus VB. If you calculate VA will, you can just calculate it simply using K rho by 2 R 4 by 5 4 by 3 pi r cube. You can just simplify it. This comes out to be, this will become r square. 2 gets cancelled with 4. Similarly, you calculate VB. When you calculate the difference will come out to be rho 4 by 3 pi r cube. You will equate it with this. And finally, when you equate both these things, you will get the answer to be, you will see that for your this question, the value of n will actually come out to be 18. Okay, just need to simplify, take the difference and equate. You are already given this thing. Now question number 17. Question number 17 was again a easy question. You're just asked to calculate in a cyclic process. You have to calculate the heat. Delta Q is equal to du plus dw. This is a cyclic process, so du is equal to 0. This will be equal to work done. Work done is area under graph. Work done will be 5 minus 2 multiplied by 300 minus 2 100. So 200 into 3, that means 600 will be your answer. Moving forward to next question. This was also a pretty straightforward question, fact based question. You see microwaves. Microwave are used for warming the food, right? Microwave is used for warming food. So P should match with 2. Then ultraviolet rays, UV rays, ROs are coming these days in market. So UV rays are used for purifying water. So Q should match with 1. You will see that only there is only one option. There is only one such option, right? So P should be 1 and we see there are two options. Q should be, sorry, P should be 2. There are two options, second and third, and Q should be 1. So option number 2 should be your correct answer. Option number 2 should be your correct answer. Question number 19. Question number 19, you were told that a car is traveling on a racetrack, radius is 50. The only catch in this question was that they have mentioned wear and tear should be minimum. That means because wear and tear should be minimum, you have to ignore the friction. When you ignore the friction, you just need to simply take one formula, that is V is equal to root Rg tan theta. Root Rg tan theta. So your theta will come out to be, when you substitute the values, your tan theta will come 1 by 5. Theta will be tan inverse 1 by 5. Option number 4. Question number 20. Question number 20, you are asked to calculate the average speed. Average speed is in fact equal to your total distance divided by total time. You need to calculate the total distance divided by total time. How can you calculate? So first you need to calculate the velocity. You are given x as a function of time. Velocity will come out to be 2t minus 6. You are asked to calculate the average velocity from t is equal to 0 to 2 is equal to 6. First you need to calculate if the particle is turning or taking a U-turn, like somewhere is the velocity 0. So velocity is 0 at 3 seconds. That means in between this time interval, the velocity has become 0. So for this purpose, what you will do, you will just calculate the total distance. Total distance will come out to be, I am just telling you the answer directly. Total distance will come out to be 18. Total time interval is 6 seconds. Your average speed will come out to be 18 by 6, that is 3. Okay, so option number 2. Question number 21. 21 says a point charge Q is placed inside the cavity, a solid inside a cavity within a solid isolated conducting sphere. Consider points A, B, and C as shown, where the magnitudes of electric field is given, and then you are asked to calculate the like the relation between A naught, EA, EB, and EC. Right? You have kept the charge over here. That means it will induce a negative charge over here in the inner side of the cavity, and this will induce a positive charge on the outer surface of the sphere, right? So taking this same thing, so EC should be equal to your EB and EC intensity should be equal to 0, and in fact the intensity on at point A should be equal to non-zero, right? So your correct answer should be option number 1 in this case, right? So moving forward now, question number 22. Question number 22 says that In measurement of viscosity of liquids using terminal velocity, you're given but having different densities. Speed v, yeah, you need to find out the ratio. So over here, what you need to use, the formula for terminal velocity, 2 by 9 r square g upon eta sigma minus rho, right? So if you just take rho out as a common, so this formula will become 2 r square g rho by 9 eta. This will become sigma by rho minus 1. You just need to check that when this ratio, on the x-axis you are given sigma by rho ratio, when this ratio becomes 1, your terminal velocity should become 0. That is not happening in your first graph, that is not happening in second, that is not happening in third. This is only happening in your fourth graph. So this should be your answer, right? Question number 23. 23 says a ray of light, you are given 3 different photoelectric cells, 1, 2 and 3, threshold frequency, threshold wavelength is given, and you are asked about the stopping potential, right? So for the first case, your lambda 1 is less than lambda. That means no emission will take place because the value, the incident wavelength is less than the threshold value. No incident, that means V1 should be equal to 0, right? You can see that in two options. Then lambda 2 is greater than lambda and lambda 3 is very, very greater than lambda. If this is very, very greater than lambda, this means the velocity with which the electrons will release in this case, that will be quite high because there is a very large wavelength difference, right? So that means V3 should have a very, very, very greater value. Then V2 should be less than that and V1 is 0. So option 4 should be your correct answer. Question number 24. 24 says a current I0 flows through a metallic circular loop of radius r as shown. You need to find out the you are told resistance of the segment ABC. This segment ABC, resistance of this segment is half that of ADC, right? We need to calculate, this is half. If this is R, then this is R by 2. We need to calculate the magnetic field at the center of the loop. Now you will just notice one thing, if this current is coming from here, it will divide in this like this, and you will see that there are two segments. This wire has R by 2, this is R resistance, and both these segments will actually have the magnetic fields in opposite direction. Like due to R2 it will be out of the plane, and due to R by 2, that is ABC segment, it will be out of the plane. Due to R resistance ADC, it will be into the plane. That means both the magnetic fields are opposite to each other. That means you just need to basically subtract it. So when you subtract it, you just need to write the value, right? So resistance is half. When you just find out the magnetic field will be mu naught by 4 into I by 3, that is mu naught I by 12. Option number 4. Then question number 25. Question number 25 says a particle of mass m moves along the horizontal. So this was a good question. Again, not very difficult, not very easy. You are given it moves between x is equal to 0 to x is equal to L, but your coefficient of kinetic friction is changing. You need to calculate the value of n wherein you're given the total work done. So work done is actually equal to F dot x, right? F dot x, and your friction will be equal to mu into mg, right? Mu into mg dx, right? dw should be equal to mu mg dx. Now I'll solve it over here. So your work done will now be this work done should be negative because displacement is happening in the opposite direction to friction. So this will be mu naught. You can just replace mu with mu naught minus alpha x, right, into mg. So when we open the bracket into dx, when we open the bracket, it will become mu naught mg L plus alpha mg L square by 2. Now we are given a condition that this becomes 0 when the value of x becomes L. That means if in this equation mu naught minus alpha L, this value will become 0. That means alpha will be equal to mu naught by L. You need to substitute this over here. When you substitute this, you will get the work done as minus mu naught mg L by 2. That means the value of n is 1 by 2. Option number 3. Value of n will come out to be 1 by 2. Moving forward to question number 26. So 26 was again a relatively easy question. It was just based on the one of the Kepler's law. So Kepler's law says that a square of the time period should be directly proportional to the your velocity. So you can just make use of the formula t square is equal to 4 pi square upon gm r cube. That means time period is simply directly proportional to r raised to the power 3 by 2. So option number A should be your correct answer in this case. Now moving forward, question number 27. 27 says you are given two solid spheres, you are given two axes IA and IB, you need to find out the difference of moment of inertia, right? So for calculating this IA, you were just supposed to use both the theorems, theorem of parallel axis and perpendicular axis, right? When you calculate IA, I will just write the expression for IA and IB, and then you can calculate the difference. Like you can check the difference. I'll just write. So IA will come out to be 2 by 5 mr square plus 2 by 5 small m small r square plus small m capital R plus R whole square. This will come out to be IA. Then IB will be 2 by 5 small mr square plus 2 by 5 capital MR square plus capital M R plus R whole square. Now you need to find out the difference. So this terms get cancelled with this. So both the first two terms get cancelled and the third terms of both remain, and when you find out the difference of these, this difference will come out to be small m minus capital M capital R plus small r whole square. Okay, so this will be option number 1 for our this question. Moving forward now to question number 28. Question number 28, this was a simple lens maker based a formula based question. You first need to calculate the value of u, and then corresponding to that you need to calculate the position of the image. So first we calculate the what will be the value of the this our v. So basically for L1 you are given the object distance is 30, focal length is given. For L1 whatever will be the distance of image, that distance of image for L1 will be the distance of object for L2. That image will actually work as a virtual object for L2, right? So when you calculate, in the first case, you will put 1 by f is equal to 1 by v minus 1 by u. F is given 10, u is given, u will be minus 30. When you calculate, v will come out to be 15 centimeter. Distance between both the lenses is given 3 centimeter. So this value from here, from this second lens will be equal to 12. Now for second lens, you will again apply the formula. U will be equal to plus 12 in this case. U will be 1 by f is equal to 1 by v minus 1 by u. You need to calculate v. When you calculate v will come out to be minus 60 from over here. Minus 60 means it is in this side. So that means minus 60 centimeter to the left, we'll just check to the left of. So 60 centimeter, we see two options. Within these two options, there should be left of the concave lens. That means on the left side. This is your concave lens and this is left side, right? Moving forward to next question 29. 29 says ideal Zener diode with breakdown voltage of minus 3 volts. So this was a simple question. For 29 question, your answer will be 3 volts. Okay, your answer will be 3 volts. Then, so basically, like this Zener diode will actually enter the breakdown region. Okay. Moving forward, question number 30. Question number 30 says three identical capacitors P, Q, and S, each of capacitance C, connected to a battery of voltage V as shown. You need to find out the ratio of UP, that is the total energy versus the energy stored in capacitor P. You can just simply use the formula half CV square. So both these capacitors are in series, the potential will become half. This whole will be potential V, identical capacitor, so V by 2, right? So UP, energy stored in P will be half C V by 2 whole square divided by total energy will be half your total capacitance. This is C, this will become C by 2, C plus C by 2 will become 3C by 2. 3C by 2 V square. So half gets cancelled with half, C gets cancelled with C, V square gets cancelled with V square. What you are left with? You are left with 1 by 2 into 2 by 3. Not 1 by 2, 2 by 3. Here you have square. This was V square. So this is 1 by 4 into 2 by 3. So you will get 1 by 6. So ratio is answer will be option number 3. Ratio is 1 by 6. Moving to question number 31. Question number 31 says conducting loop area is given. You are asked to calculate the power. So first, using the area, you can calculate your using the formula of flux. Flux is basically B dot A dot product of field with area. Field is constant. So you can just say that flux is equal to B dot product with A naught 1 plus sine omega t sine t. We need to calculate EMF first. EMF is minus d phi by dt. You calculate this. This will be minus B A naught sine cos t. Then we need to calculate power. Power is simply E square by R. Power will become minus B A naught whole square by R cos square t. That means your graph of power will be directly proportional to cos square, right? And if you see at t is equal to 0, your power should be maximum, that is 1. Like the this whole cos thing will become 1, and at t is equal to pi by 2, power should be 0. That means your graph should look somewhat like the first option, right? Because in none of the other graphs, yeah. So you might have a confusion in first and fourth graph. You just need to check them carefully. In the fourth graph, initial and final point power is also 0. That will not be true. It is basically saying at t is equal to 0, t is equal to pi by 2, and t is equal to pi. At all 3 points, power will be 0. That is not possible. Moving forward to question 32. 32, you're given two circuits. So 32 was an interesting question. You just need to find out the like how does the current varies, right? So for current, you are given that temperature coefficient of resistance is given plus A and minus A in for both the wires. Over here, if you see, if you find total resistance, resistance will come by adding these two things, and when you add these, your alpha delta t terms gets eliminated. So over here in the very first circuit, when you find current in the first circuit, current will be delta v by 2r. 2r is constant, delta v is constant, so first ia is constant, right? But in the second circuit, if you find out, your resistance will be not 2, your resistance will be R1 R2 by R1 plus R2, right? If you see, you will get one term with alpha. You will get a alpha term, right? And that alpha term will in fact look like your resistance will be R0 by 2, 1 minus alpha square delta t square. That means as and when your temperature increases, this whole term will decrease. That means IB will actually this whole term will decrease. This whole term is decreasing. That means resistance is decreasing. Resistance is decreasing. That means current is increasing. That means your option should be last option. IA will remain constant. IB will increase linearly at a same rate. Then question number 33. Again, I would say a relatively easy question based on your simple pendulum. In question number 33, you are given a pendulum bob of mass m at rest, hanging vertically. You are saying that this hits elastically. That means the complete velocity is not transferred, right? It is not perfectly elastic. Collision is not perfectly elastic. So you know velocity is simply root 2gh. Height is v square by 2g. Your velocity is given 10. So 10 into 10 divided by 2 into 10. 10 gets cancelled with 10. 2 5s are 10. So height, the value of h will come out to be 5. Moving forward to question number 34. Question number 34 says that you are given a cylindrical cork of uniform velocity, uniform density rho. Rho 1 and rho 2, two densities are given, and you are given the time period, right? So you are given first when the time period is t, your density is rho 1. You just need to remember the formula. Time period was equal to 2 pi root m upon a rho g, right? That means time period is inversely proportional to root of density. First, when time period is t, time period is 1 upon root rho 1. When time period is 2t, your density is rho 2. You need to find out the ratio of rho 2 by rho 1. So rho 2 by rho 1, when you divide both these equations, you will get root rho 2 by under root rho 2 by rho 1 is equal to 1 by 2. You square both sides, you will get 1 by 4. Your ratio will come out to be 1 upon 4, right? So moving forward to our next question. 35 again, a very simple and a very easy straight form, direct straightforward formula based question. In this question you are given mean free path of molecules of ideal gas A. Mean free path of A is half of mean free path of B. Formula for mean free path is 1 upon root 2 pi n d square. N is your number density of molecules, d is your diameter of molecules. You just need to find out the number density ratio. You are given the diameter of A is twice. Diameter of A is twice the diameter of B. You just need to substitute the values. You need to use this relation lambda A is equal to lambda B by 2, and then you will be able to find this relation. So when you simplify, you will get Na is equal to Nb by 2. Your relation will be option number 3. Question number 36. Question number 36, we are given a nuclear reaction. You are given the masses. You need to calculate the Q value. So, first of all, you need to calculate the mass defect, delta M. Delta M will come out to be 238.05 minus, you add both these values. This is 4.003. You will get 238.046. When you find, your answer will be 0.004. So this will be your delta M, the mass defect. And then for calculating the Q value, you know the value of 1U. This comes in U. 1U is equal to 931.5 MeV upon C square, right? Basically in mega electron volts. Me square eV by C square. You are already given this value. You need to multiply it. When you multiply, you will get 3.726 MeV. You are asked the Q value in keV, that means in kilo electron volts. So if you need to convert it in kilo, mega is 10 raised to the power 6, kilo is 10 raised to the power 3. You just need to multiply it by 1000, so this becomes 3726. Option number 4, 3726 keV. Question number 37. I believe there was no other question which was easier than this question. This was a simple question. They were just asking you to take the correct formula. You just need to choose the correct formula for inductance of a solenoid. You are given the your a long straight solenoid having length R, L, radius R. Your formula for inductance of the solenoid is mu naught n, mu naught pi n square R square L. You're just supposed to choose the formula. Moving forward, question number 38. Again, I would say a relatively easy question. If you are very well versed, or if you have just performed your practicals in your school correctly, or if you have studied the theory of your practicals, actually what you do and how you do. So you were asked that index correction will be required in which of the measurements. So we know when you need to find out the speed of sound using resonance tube, when you are choosing calculating speed of sound, so while calculating the speed of sound, you are actually asked to use the length, right? So whenever you are asked to measure the length or take the length somewhere, you need to fix your ends. End correction is needed in that case. So end correction will be needed in calculating sound. Then measurement of resistance of wire using meter bridge, again you need to calculate the accurate length. So again end correction will be needed, that means the length. And in the first option also, you are asked you are saying measurement of gravitational acceleration using simple pendulum. Simple pendulum formula was 2 pi root L by G. Again length, wherever we need to calculate actual length, perfectly length, we need to basically apply end correction. Over here you are asked to question is asking us index correction. So index correction will be used in optical bench while you are calculating the focal length, right? Index correction, it basically says that you need to fix your needle or the pointer at a very accurate and a precise value. Then question number 39. 39 says the temperature of a metallic sphere of radius r is increased by a small amount delta T. Linear coefficient of thermal expansion is alpha. You need to find out the approximate change in the volume. Approximate change in the volume we need to find out. We know gamma is equal to 3 alpha. Change in volume should be equal to gamma V delta T, right? So gamma becomes 3 alpha, volume becomes 4 by 3 pi r cube, and your delta T remains delta T. 3 gets cancelled with 3. Your answer comes 4 pi r cube delta T into alpha. Option number 2. Then moving forward to question number 40. Question number 40, you are given a photon and an electron and each of 20 eV energy, 20 electron volt energy move in free space. You need to find out the ratio of linear momentum of electron to that of photon. I'll just clear some space over here. So you need to calculate the ratio of linear momentum of electron to photon. I'll write it as pH. So for electron, we already know a direct formula root 2 mk, and for photon, we can use E upon C, right, for calculating the momentum. You just need to substitute the values. Like a difficult part was the calculation thing, right? So 2, your value of mass is already given 9 into 10 raised to the power minus 31, then 20 into 1.6 into 10 raised to the power minus 19, divided by E is given to be 20 EV. So 20 into 1.6 into 10 raised to the power minus 19, divided by value of C, 3 into 10 raised to the power 8. When you will solve this, you will simplify this. This will come out to be 225. Okay. Then question number 41. So question number 41, you need to solve this question very carefully, because when you solve using, so like there is a sort of a catch in this question. What is the catch? When you calculate it using directly the formula for velocity. That means when you use this Vn is equal to this 2.18 into 10 to the power 6 divided by n. If you try using this formula, you will approximate, right? You will get the value of n as 5.06 into 10 raised to the power 5, and approximately you will take it as 5, but that will make a huge difference. When you find out the radius of the fifth orbit, you will get the answer as 0.84 something, right? And that is not actually in the in any of the options. And you might have felt, if you chose that way of solving this question, you might have felt that there is no correct answer, right? But actually there is a correct answer. So this question is actually not wrong. There is a correct answer. We'll just discuss it over here. We need to use the same formula. Your centripetal force mv square by r is equal to electrostatic force 1 upon 4 pi epsilon naught E square by r square. R square, this gets cancelled with r, 1 square gets cancelled with r, and we need to simplify. We get the formula of r as 1 upon 4 pi epsilon naught. I'll do one thing. I'll just solve this question in note 3. So like it's clearly visible, because it might, like, this was an important question, and I have seen, like, whatever discussions are going on right now, most of the most of the people are confused for this question, right? So using this formula, when you will calculate your r will come out to be 1 upon 4 by epsilon naught E square by mv square. I'll just solve it here itself. R you will get as you will get as 1 upon 4 pi epsilon naught E square upon mv square. You just need to put in the values. You have a value of k 9 into 10 raised to the power 9, 1.6 10 raised to the power minus 19 whole square, divided by mass m in, 9 into 10 raised to the power minus 31. 25.6 into 10 raised to the power 10. 9 gets cancelled with 9, then 10 raised to the power 9, 10 raised to the power 10, 10, 1 10 remains. And when you solve this, when you try to simplify this, you will get the value as 1 by 10 into 10 raised to the power minus 8. That means 10 raised to the power minus 9. That means 1 into 10 raised to the power minus 9. So when you compare it with the values given in your question, answer is given as x into 10 raised to the power minus 9. So the value of x comes out to be 1. If you would have used the different formula, then you might have arrived at 0.86, right? And that might have caused a confusion. Then talking about the remaining 4 questions, I would say these 4 questions which are remaining, all these 4 questions were made to look hard, but they are not hard. Like if you see the length of this question, you might, fear that it is a difficult question. There is also a diagram, and seeing the length of this question, these questions, but these questions are relatively very easy. In this question, you are given 4 springs, like 2 different configurations, P and Q. This is P, this is Q. You were asked to calculate the ratio of EMF, right? EP versus EQ, and you are given all the springs are identical, and the time varying current is also fixed, current is also constant. And then we need to calculate the basically the ratio of your EMF. So we know the ratio of EMF is basically d phi I by dt. That means L di by dt. I can write L dit by dt, right? L multiplied by di by dt. When I see my P configuration, I see this is L, this is L. So EMF simply between these 2 points, between A and B, there is only one inductor. So my EMF will be, EP will be L di by dt, minus L di by dt, right? But when I see over here, when the current comes in this and both the inductors are identical, current will actually divide in two equal parts, right? So that means over here, when I find the EMF between points A and B, my EMF will actually come out to be minus L d by dt of IT by 2. IT is a time varying current. That means my EMF in Q configuration is exactly half, right? EMF in Q configuration is exactly half of that. So my ratio will come out to be 2, right? Option number 3 will be my correct answer in this case. Then question number 43, we are given adiabatic expansion 1 mole, the value of N is 1, monatomic gas, gamma is 5 by 3, temperature change delta T is equal to 60 K to 50 K, right? 60 Kelvin to 50 Kelvin, that means minus 10 Kelvin. We need to calculate the work done. So work done, we can simply use the first law. Your adiabatic process heat is 0, Q is 0. That means delta U is equal to minus W, W is equal to minus delta U. And if I need to calculate delta U, I'll just write it over here. Delta U will be simply NCV delta T. Value of N is 1 mole gas. CV for a monatomic gas is 3R by 2. Delta T is minus 10, right? So this becomes 2 5s are 10, 5 3s are 15, minus 15R. We are asked to calculate the work done. Work done is plus 15R, right? And then we are given the value of R. R is 8.3. When you multiply 15 by 8.3, you will get the value as 124.5 joules. Option number 2. Moving forward, question number 44. This was a moderate difficulty question. Two concepts were being used in this question. In the very first thing, they are mentioning that there is a pressure difference and like they are given the area and velocity. So first you had to use the equation of continuity. AP Vp is equal to AQ Vq. Aerial velocity, velocity through a particular area, equation of continuity. You find 40 Vp is equal to 20 Vq. We find the relation velocity at point Q is just double the velocity of point P, right? And then we need to find out the rate of flow. So for that we had to use Bernoulli's theorem, right? We had to use Bernoulli's theorem. Bernoulli's theorem, P, your pressure head at point P plus rho GHP plus half rho Vp square is equal to PQ plus, I'll just write this solution over here. PP plus rho GHP plus half rho Vp square is equal to PQ plus rho GHQ plus half rho VQ square, right? And you will notice that question is saying that P and Q are at the same level, right? Because they are at the same level, that means their height difference will become 0. So we will just these both, or we can say like because they are at the same level, the difference of these two terms will come out to be 0. So these two terms get cancelled with each other. PP minus PQ, pressure difference is equal to half rho VQ square minus half rho Vp square. Pressure difference is given 15 is equal to half into 1000 density 2 Vp whole square minus Vp whole square. This becomes 2 5s are 10, 500, and we simplify it. 5 3s are 1500. 3 by 100 is equal to 4 Vp square minus Vp square. This becomes 3 Vp square. 3 gets cancelled with 3. Vp square is equal to 10 to the power minus 2. Vp comes out to be 0.1. But mind it, Vp comes out to be 0.1, but we are asked the value in centimeter cube per second. This is in meters, right? So we will multiply it by 100. So this will come out to be 10 centimeter per second. Velocity will come in 10 centimeter per second. We are asked to calculate the rate of flow. That means rate of change of volume with respect to time. So that will simply be 40 multiplied by 10. That means 400. Option C. Okay. Answer will be 400. Now coming to our last question. Coming to our last question of the exam. Question number 45 says a thin horizontal disc is rotating. This was a pretty simple question. You just had to observe one single thing. Okay. And what was that thing? You were just asked to calculate the ratio of the angular momentum. Now, just keep in mind that angular momentum of body about any point is simply equal to angular momentum of center of mass, angular momentum of center of mass plus R cross M VCM, right? R cross MV, right? And we are given the question mentioned a very important thing which actually made this question a very easy and simple question. Question says that the rod is fixed passing through its fixed center O. This means this center is fixed. This means the velocity of center of mass is 0. This means like basically the angular momentum of center of mass is 0. Now, sorry, not the angular momentum. Velocity of center of mass is 0. Yeah, velocity of center of mass is 0. That means this VCM will always come out to be 0, right? This velocity will always come out to be 0. And wherever we find the, like, if you find the velocity, the angular momentum at about any point, that is always going to become equal to angular momentum of center of mass, right? That means if I calculate angular momentum about A, that will also be LCOM, like angular momentum about center of mass, and LB will also be angular momentum of center of mass. When I take the ratio of both of these, my ratio will come out to be 1, because only this second terms become 0, only this first term is left, and this first term will remain constant in all the cases. So this was all about your 45 questions in your physics paper. I would again say, like, I would definitely say that this was not a paper wherein you could have easily scored like full on full marks. Like out of 45 questions, I believe it will be pretty difficult for anyone to score a perfect 180. But yeah, I would say like it was from a moderate to hard difficulty level. There were some questions wherein the calculation was pretty tricky, and if by chance you got stuck in those questions, then you would have lost a large amount of time. So it was like, it is not as easy, or as I would say, if we compare it with the third May paper, it was not, the paper was not at all at that level. It was not at all that easy, but it was not very difficult. It is somewhere between moderate to difficult, right? So even if you don't have to worry, why am I again and again emphasizing on this? Even if you're not able to score, whatever you have expected, then you don't have to feel disheartened, because if a paper is difficult, it is difficult for everyone, and difficult paper will always benefit students who have worked hard, right? Because even at a lower score, the everything, your AIR, whatever rank you will get, all these things are relative. So if a paper is difficult, it is difficult for everyone. It is not just difficult for you. So you don't have to worry about that in case you're not getting the marks as per your expectation. Just keep your hopes high. Your official answer key will also be out in a very short period of time, and then your results will also be declared very shortly. So just don't panic now. The main thing is done. Just take some time, relax, and then energize yourself back. Take a break, take some rest. You're just given your paper. Take a break, take some rest, and just re-energize yourself in the next 1 to 2 days, and then we'll start with the next phase of your journey, right? Thank you so much for watching today's live, and just stay tuned to the channel for your chemistry paper discussion, right? Thank you so much, and I hope all of you are scoring good. Or even if you're not scoring good, don't worry, everything is going to be fine, right? You will get a very good college, you will get you will fulfill your dream of becoming a doctor. I am quite confident on that thing, right? And you have already conquered a really really big thing. You have written your paper again, and you are sitting here and you are calculating your marks. So it is, it is quite a big thing in itself. So a very very congratulations on that, and don't feel disheartened, don't feel demotivated. Everything is going to be fine. Thank you so much for watching. See you in the next video.